Regional effects of climate change. Regional effects of climate change are long-term significant changes in the expected patterns of average weather of a specific region due to climate change. The world average temperature is rising due to the greenhouse effect caused by increasing levels of greenhouse gases, especially carbon dioxide. When the global temperature changes, the changes in climate are not expected to be uniform across the Earth. In particular, land areas change more quickly than oceans, and northern high latitudes change more quickly than the tropics, and the margins of biome regions change faster than do their cores. Regional effects of climate change vary in nature. Some are the result of a generalized global change, such as rising temperature, resulting in local effects, such as melting ice. In other cases, a change may be related to a change in a particular ocean current or weather system. In such cases, the regional effect may be disproportionate and will not necessarily follow the global trend. The increasing temperatures from greenhouse gases have been causing sea levels to rise for many years. There are three major ways in which global warming will make changes to regional climate: melting or forming ice, changing the hydrological cycle of evaporation and precipitation, and changing currents in the oceans and air flows in the atmosphere. The coast can also be considered a region and will suffer severe impacts from sea level rise. The Arctic, Africa, small islands, and Asian megadeltas, and Australia are regions that are likely to be especially affected by future climate change. Africa is one of the most vulnerable continents to climate variability and change because of multiple existing stresses and low adaptive capacity. Climate change is projected to decrease freshwater availability in Central, South, East, and Southeast Asia, particularly in large river basins. With population growth and increasing demand from higher standards of living, this decrease could adversely affect more than 1 billion people by the 2050s. Small islands, whether located in the tropics or higher latitudes, are already exposed to extreme weather events and changes in sea level. This existing exposure will likely make these areas sensitive to the effects of climate change. Background. With very high confidence, scientists have concluded that physical and biological systems on all continents and in most oceans had been affected by recent climate changes, particularly regional temperature increases. Impacts include changes in regional rainfall patterns, earlier leafing of trees and plants over many regions, movements of species to higher latitudes and altitudes in the northern hemisphere, changes in bird migrations in Europe. The human influence on the climate can be seen in the geographical pattern of observed warming, with greater temperature increases over land and in polar regions rather than over the oceans. 6. Using models, it is possible to identify the human signal of global warming over both land and ocean areas. 6. Especially affected regions. The Arctic, Africa, small islands, and Asian megadeltas are regions that are likely to be especially affected by future climate change. Within other areas, some people are particularly at risk from future climate change, such as the poor, young children, and the elderly. The Arctic. The Arctic is likely to be especially affected by climate change because of the high projected rate of regional warming and associated impacts. Temperature projections for the Arctic region were assessed by Anisimov et al. 2007. These suggested aerially averaged warming of about 2°C to 9°C by the year 2100. The range reflects different projections made by different climate models run with different forcing scenarios. Radiative forcing is a measure of the effect of natural and human activities on the climate. Different forcing scenarios reflect, for example, different projections of future human greenhouse gas emissions. Africa. Africa is likely to be the continent most vulnerable to climate change. With high confidence, Boko et al. 2007 projected that in many African countries and regions, agricultural production and food security would probably be severely compromised by climate change and climate variability. The United Nations Environment Programme UNEP 2007 produced a post-conflict environmental assessment of Sudan. According to UNEP 2007, environmental stresses in Sudan are interlinked with other social, economic, and political issues, such as population displacement and competition over natural resources. Regional climate change, through decreased precipitation, was thought to have been one of the factors which contributed to the conflict in Darfur. Along with other environmental issues, climate change could negatively affect future development in Sudan. One of the recommendations made by UNEP 2007 was for the international community to assist Sudan in adapting to climate change. Located in the Greater Horn of Africa region, Kenya also experiences high vulnerability to the impacts of climate change. The main climate hazards include droughts and floods, with current projects forecasting more intense and less predictable rainfall. In addition, other projections anticipate temperatures rising by 0.5 to 2 degc. In crowded, urban settlements in Nairobi, Kenya, the conditions of informal settlements or slums may exacerbate the impacts of climate change and disaster-related risk. In particular, the living conditions of large informal settlements often create a warmer microclimate due to home construction materials, lack of ventilation, sparse green space, and poor access to electrical power and other services. To mitigate climate change-related risks in these informal neighborhood settlements, it will be important to upgrade these settlements through urban development interventions that are built for climate resilience. Such interventions include upgrades for waste. Small and large islands. Small islands developing states are especially vulnerable to the effects of climate change. Harsh and extreme weather conditions is a part of everyday life, however. As the climate changes, these small islands find it difficult to adapt to the rising scale and intensity of storm surges, saltwater intrusion, and coastal destruction. The projected damage to small islands and atoll communities will be a consequence of climate change caused by developing countries that will disproportionately affect these developing nations. Sea level rise and increased tropical cyclones are expected to place low-lying small islands in the Pacific, Indian, and Caribbean regions at risk of inundation and population displacement. South Pacific and atoll nations. According to a study on the vulnerability of island countries in the South Pacific to sea level rise and climate change, financially burdened island populations living in the lowest lying regions are most vulnerable to risks of inundation and displacement. On the islands of Fiji, Tonga, and Western Samoa, for example, high concentrations of migrants that have moved from outer islands inhabit low and unsafe areas along the coasts. Atoll nations, which include countries that are composed entirely of the smallest form of islands, called motus, are at risk of entire population displacement. These nations include Kiribati, Maldives, the Marshall Islands, Tokelau, and Tuvalu. According to a study on climate dangers to atoll countries, characteristics of atoll islands that make them vulnerable to sea level rise and other climate change impacts include their small size, their isolation from other land, their low income resources, and their lack of protective infrastructure. A study that engaged the experiences of residents in atoll communities found that the cultural identities of these populations are strongly tied to these lands. The risk of losing these lands therefore threatens the national sovereignty or right to self-determination of atoll nations. Human rights activists argue that the potential loss of entire atoll countries, and consequently the loss of cultures and indigenous lifeways, cannot be compensated with financial means. Some researchers suggest that the focus of international dialogues on these issues should shift from ways to relocate entire communities to strategies that instead allow for these communities to remain on their lands. The Caribbean, the Philippines. According to the UN Office for the Coordination of Humanitarian Affairs (OCHA), the Philippines is one of the most disaster-prone countries in the world. The archipelago of 7,109 islands is situated along the Pacific Ocean's typhoon belt, leaving the country vulnerable to an average of 20 typhoons every year, 5 of which are destructive. In addition, the Philippines is also located within the Pacific Ring of Fire, which makes the country prone to frequent earthquakes and volcanic eruptions. Compounding these issues, the impacts of climate change, such as accelerated sea level rise, exacerbate the state's high susceptibility to natural disasters, which also flooding and landslides. Middle East, Middle East, 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 East. The region of Middle East is one of the most vulnerable to climate change. The impacts include increase in drought conditions, aridity, heat waves, sea level rise. If greenhouse gas emissions are not reduced, the region can become uninhabitable before the year 2100. South Asia, Southeast Asia. The 10 countries of the Association of Southeast Asian Nations, ASEAN, are among the most vulnerable to the effects of climate change in the world. However, the region's climate mitigation efforts are not commensurate with the threats and risks it faces. Afghanistan. Climate change impacts in Afghanistan culminate from overlapping interactions of natural disasters due to changes in the climate system, conflict, agricultural dependency, and severe socioeconomic hardship. Combined with infrequent earthquakes, climate-related disasters such as floods, flash floods, avalanches, and heavy snowfalls on average affect 200,000 people every year, causing massive losses of lives, livelihoods, and properties. Unfortunately, these interacting factors, particularly protracted conflicts, which erode and challenge the ability to handle, adapt to, and plan for climate change at individual and national levels, often turn climate change risks and hazards into disasters. Ice cover changes. Permanent ice cover on land is a result of a combination of low peak temperatures and sufficient precipitation. Some of the coldest places on Earth, such as the dry valleys of Antarctica, lack significant ice or snow coverage due to a lack of snow. Sea ice, however, may be formed simply by low temperature, although precipitation may influence its stability by changing albedo, providing an insulating covering of snow and affecting heat transfer. Global warming has the capacity to alter both precipitation and temperature, resulting in significant changes to ice cover. Furthermore, the behavior of ice sheets, ice caps, and glaciers is altered by changes in temperature and precipitation, particularly as regards the behavior of water flowing into and through the ice. Arctic sea ice. Recent projections of sea ice loss suggest that the Arctic Ocean will likely be free of summer sea ice sometime between 2059 and 2078. Models showing decreasing sea ice also show a corresponding decrease in polar bear habitat. Some scientists see the polar bear as a species which will be affected first and most severely by global warming because it is a top-level predator in the Arctic, which is projected to warm more than the global average. Recent reports show polar bears resorting to cannibalism, and scientists state that these are the only instances that they have observed of polar bears stalking and killing one another for food. Antarctica. The Antarctic Peninsula has lost a number of ice shelves recently. These are large areas of floating ice which are fed by glaciers. Many are the size of a small country. The sudden collapse of the Larsen B ice shelf in 2002 took 5 weeks or less and may have been due to global warming. Larsen B had previously been stable for up to 12,000 years. Concern has been expressed about the stability of the West Antarctic ice sheet. A collapse of the West Antarctic ice sheet could occur within 300 years as a worst-case scenario. Rapid sea level rise 1 m per century is more likely to come from the WISE than from the Greenland ice sheet. Greenland. As the Greenland ice sheet loses mass from calving of icebergs as well as by melting of ice, any such processes tend to accelerate the loss of the ice sheet. The IPCC suggest that Greenland will become ice-free at around 5 Celsius degrees over pre-industrial levels, but subsequent research comparing data from the Eemian period suggests that the ice sheet will remain at least in part at these temperatures. The volume of ice in the Greenland sheet is sufficient to cause a global sea level rise of 7 meters. It would take 3,000 years to completely melt the Greenland ice sheet. This figure was derived from the assumed levels of greenhouse gases over the duration of the experiment. In reality, these greenhouse gas levels are of course affected by future emissions and may differ from the assumptions made in the model. Glaciers. Glacier retreat does not only affect the communities and ecosystems around the actual glacier, but the entire downstream region. The most notable example of this is in India, where river systems such as the Indus and Ganges are ultimately fed by glacial meltwater from the Himalayas. Loss of these glaciers will have dramatic effects on the downstream region, increasing the risk of drought as lower flows of meltwater reduce summer river flows unless summer precipitation increases. Altered patterns of flooding can also affect soil fertility. The Tibetan Plateau contains the world's third largest store of ice. Kindap, the former head of the China Meteorological Administration, said that the recent fast pace of melting and warmer temperatures will be good for agriculture and tourism in the short term, but issued a strong warning. Temperatures are rising 4 times faster than elsewhere in China, and the Tibetan glaciers are retreating at a higher speed than in any other part of the world. Permafrost regions. Regions of permafrost cover much of the Arctic. In many areas, permafrost is melting, leading to the formation of a boggy, undulating landscape filled with thermokarst lakes and distinctive patterns of drunken trees. The process of permafrost melting is complex and poorly understood since existing models do not include feedback effects such as the heat generated by decomposition. Arctic permafrost soils are estimated to store twice as much carbon as is currently present in the atmosphere in the form of CO2. Warming in the Arctic is causing increased emissions of CO2 and methane CH4. Precipitation and vegetation changes. Much of the effect of global warming is felt through its influence on rain and snow. Regions may become wetter, drier, or may experience changes in the intensity of precipitation, such as moving from a damp climate. These changes may have a very severe impact on both the natural world and human civilization, as both naturally occurring and farmed plants experience regional climate change that is beyond their ability to tolerate. A U.S. National Oceanic and Atmospheric Administration NOAA analysis published in the Journal of Climate October 2011 and cited on Joseph J. Rahm's climateprogress.org found that increasing droughts in the Middle East during the wintertime, when the region traditionally receives most of its rainfall to replenish aquifers, and anthropogenic climate change. For Earth System Research Laboratories Martin Hoerling, the magnitude and frequency of the drying that has occurred is too great to be explained by natural variability alone, and this is not encouraging news for a region that already experiences water stress, because it implies natural variability alone is unlikely to return the region's climate to normal. The lead author of the paper, 12 of the world's 15 most water-scarce countries, Bahrain, Qatar, Jordan, Saudi Arabia, Yemen, Oman, the United Arab Emirates, Kuwait, Israel, and Palestine, are in the Middle East. Arctic and Alpine regions. Polar and alpine ecosystems are assumed to be particularly vulnerable to climate change, as their organisms dwell at temperatures just above the 0-degree threshold for a very short summer growing season. Predicted changes in climate over the next 100 years are expected to be substantial in Arctic and subarctic regions. Already there is evidence of upward shifts of plants in mountains, and in Arctic shrubs are predicted to increase substantially to warming. Amazon. One modeling study suggested that the extent of the Amazon rainforest may be reduced by 70% if global warming continues unchecked, due to regional precipitation changes that result from weakening of large-scale tropical circulation. North America. By the year 2100, severe storms that used to happen on average once every 2050, or 100 years, 20 year, 50-year and 100-year storms may happen every couple of years, according to a study published in June 2020 in Proceedings of the National Academy of Sciences. Sahara. Some studies suggest that the Sahara Desert may have been more vegetated during the warmer mid-Holocene period, and that future warming may result in similar patterns. Sahel. Some studies have found a greening of the Sahel due to global warming. Other climate models predict a doubling of the number of anomalously dry years in the Sahel by the end of the century. Desert expansion. Expansion of subtropical deserts is expected as a result of global warming, due to expansion of the Hadley cell. Coastal regions. Global sea level is currently rising due to the thermal expansion of water in the oceans and the addition of water from ice sheets. Because of this, their low-lying coastal areas, many of which are heavily populated, are at risk of flooding. Areas threatened by current sea level rise include Tuvalu and the Maldives. Regions that are prone to storm surges, such as London, are also threatened. With very high confidence, IC 2007 projected that by the 2080s many millions more people would experience floods every year due to sea level rise. The numbers affected were projected to be largest in the densely populated and low-lying megadeltas of Asia and Africa. Small islands were judged to be especially vulnerable. Ocean effects. North Atlantic region. It has been suggested that a shutdown of the Atlantic thermohaline circulation may result in relative cooling of the North Atlantic region by up to 8°C in certain locations. Recent research suggests that this process is not currently underway. Tropical surface and troposphere temperatures. In the tropics, basic physical considerations, climate models, and multiple independent data sets indicate that the warming trend due to well-mixed greenhouse gases should be faster in the troposphere than at the surface. By region, highlights of recent and projected regional impacts are shown below. Impacts on Africa. African countries are more affected by climate change because of the dependence on agriculture, as well as their poor financial, technical, and institutional capacity to adapt. Africa is one of the most vulnerable continents to climate variability and change because of multiple existing stresses and low adaptive capacity. Existing stresses include poverty, political conflicts, and ecosystem degradation. By 2050, between 350 million and 601 million people are projected to experience increased water stress due to climate change. Climate change is likely to lead to the increasing frequency and severity of intense rainfall events across Africa. Since the 1980s, climate change has resulted in the tripling in the frequency of extreme storms in the Sahel region of West Africa. Climate variability and change is projected to severely compromise agricultural production, including access to food across Africa, which means there will be high food insecurity. Climate change can influence pest infestation and spread of animal disease because of increase in temperature and rainfall variability. Toward the end of the 21st century, projected sea level rise will likely affect low-lying coastal areas with large populations. Climate variability and change can negatively impact human health. In many African countries, other factors already threaten human health. For example, malaria threatens health in southern Africa and the eastern highlands. Impacts on Arctic and Antarctic. Expected impacts on the Arctic and Antarctic include climate change in the Arctic will likely reduce the thickness and extent of glaciers and ice sheets. Changes in natural ecosystems will likely have detrimental effects on many organisms, including migratory birds, mammals, and higher predators. Climate change will likely cause changes in dominance structures in plant communities, with shrubs expanding. In the Arctic, climate changes will likely reduce the extent of sea ice and permafrost, which can have mixed effects on human settlements. Negative impacts could include damage to infrastructure and changes to winter activities such as ice fishing and ice road transportation. Positive impacts could include more navigable northern sea routes. Continued permafrost degradation will likely result in unstable infrastructure in Arctic regions or Alaska before 2100, thus impacting roads, pipelines, and buildings, as well as water distribution, and cause slope failures. The reduction and melting of permafrost, sea level rise, and stronger storms may worsen coastal erosion. Terrestrial and marine ecosystems and habitats are projected to be at risk to invasive species, as climatic barriers are lowered in both polar regions. Impacts on Asia. Expected impacts on Asia include glaciers in Asia are melting at a faster rate than ever documented in historical records. Melting glaciers increase the risks of flooding and rock avalanches from destabilized slopes. Climate change is projected to decrease freshwater availability in Central, South, East, and Southeast Asia, particularly in large river basins. With population growth and increasing demand from higher standards of living, this decrease could adversely affect more than 1 billion people by the 2050s. Increased flooding from the sea and, in some cases, from rivers threatens coastal areas, especially heavily populated delta regions in South, East, and Southeast Asia. By the mid-21st century, crop yields could increase up to 20% in East and Southeast Asia. In the same period, yields could decrease up to 30% in Central and South Asia. Sickness and death due to diarrheal disease are projected to increase in East, South, and Southeast Asia due to projected changes in the hydrological cycle associated with climate change. Agricultural demand from China's crops lead to land degradation and land modifications, which in turn leads to increased greenhouse gas emissions. Environmental factor # socioeconomic drivers. Impacts on Europe. Expected impacts on Europe include wide-ranging impacts of climate change have already been documented in Europe. These impacts include retreating glaciers, longer growing seasons, species range shifts, and heat wave-related health impacts. Future impacts of climate change are projected to negatively affect nearly all European regions. Many economic sectors, such as agriculture and energy, could face challenges. In southern Europe, higher temperatures and drought may reduce water availability, hydropower potential, summer tourism, and crop productivity. In Central and Eastern Europe, summer precipitation is projected to decrease, causing higher water stress. Forest productivity is projected to decline. The frequency of peatland fires is projected to increase. In Northern Europe, climate change is initially projected to bring mixed effects, including some benefits such as reduced demand for heating, increased crop yields, and increased forest growth. However, as climate change continues, negative impacts are likely to outweigh benefits. These include more frequent winter floods, endangered ecosystems, and increasing ground instability. Impacts on South America. Expected impacts on South America include, by mid-century, increases in temperature and decreases in soil moisture are projected to cause savanna to gradually replace tropical forest in the eastern Amazon basin. In drier areas, climate change will likely worsen drought, leading to salinization, increased salt content, and desertification, land degradation of agricultural land. The productivity of livestock and some important crops such as maize and coffee are projected to decrease, with adverse consequences for food security. In temperate zones, soybean yields are projected to increase. Sea level rise is projected to increase risk of flooding, displacement of people, salinization of drinking water resources, and coastal erosion in low-lying areas. Changes in precipitation patterns and the melting of glaciers are projected. Impacts on North America. Expected impacts on North America include warming in western mountains is projected to decrease snowpack, increase winter flooding, and reduce summer flows, exacerbating competition for over-allocated water resources. Disturbances from pests, diseases, and fire are projected to increasingly affect forests, with extended periods of high fire risk and large increases in area burned. Moderate climate change in the early decades of the century is projected to increase aggregate yields of rain-fed agriculture by 5–20%, but with important variability among regions. Crops that are near the warm end of their suitable range or that depend on highly utilized water resources will likely face major challenges. Increases in the number, intensity, and duration of heat waves during the course of the century are projected to further challenge cities that currently experience heat waves with potential for adverse health impacts. Older populations are most at risk. Climate change will likely increasingly stress coastal communities and habitats, worsening the existing stresses of development and pollution. As to 2019, climate change have already increased wildfires frequency and power in Canada, especially in Alberta. Impacts on Oceania. Expected impacts on Oceania include water security problems are projected to intensify by 2030 in southern and eastern Australia and in the northern and some eastern parts of New Zealand. Significant loss of biodiversity is projected to occur by 2020 in some ecologically rich sites, including the Great Barrier Reef and the wet tropics of Queensland. Sea level rise and more severe storms and coastal flooding will likely impact coastal areas. Coastal development and population growth in areas such as Cairns and southeast Queensland, Australia, and Northland to Bay of Plenty, New Zealand, would place more people and infrastructure at risk. By 2030, increased drought and fire is projected to cause declines in agricultural and forestry production over much of southern and eastern Australia and parts of eastern New Zealand. Extreme storm events are likely to increase failure of floodplain protection and urban drainage and sewerage, as well as damage from storms and fires. More heat waves may cause more deaths and more electrical blackouts. Impacts on small islands. Expected impacts on small islands include small islands, whether located in the tropics or higher latitudes, are already exposed to extreme weather events and changes in sea level. This existing exposure will likely make these areas sensitive to the effects of climate change. Deterioration in coastal conditions, such as beach erosion and coral bleaching, will likely affect local resources such as fisheries, as well as the value of tourism destinations. Sea level rise is projected to worsen inundation, storm surge, erosion, and other coastal hazards. These impacts would threaten vital infrastructure, settlements, and facilities that support the livelihood of island communities. By mid-century, on many small islands such as the Caribbean and Pacific, climate change is projected to reduce already limited water resources to the point that they become insufficient to meet demand during low rainfall periods. Invasion by non-native species is projected to increase with higher temperatures, particularly in mid- and high-latitude islands.